Hibernate OGM general architecture in Hibernate. Here you can see general architecture of Hibernate OGM. Hibernate OGM is made possible by the reuse of a few key components. Hibernate ORM for JPA support, the NoSQL drivers to interact with the underlying data store. Optionally, Hibernate search for indexing and query purposes. Optionally, InfiniSpan's Lucene directory to store indexes in the InfiniSpan itself or many other NoSQL using InfiniSpan's wire through cache stores. Hibernate OGM itself. Hibernate OGM reuses as much as possible from the Hibernate ORM infrastructure. There is no need to rewrite a new JPA engine. The persister and the loaders, two interfaces used by Hibernate ORM, have been written to persist data in the NoSQL store. These implementations are the core Hibernate OGM. The particularities between NoSQL stores are abstracted by the notion of a data store provider and grid dialect. Data store provider abstract how to start and maintains a connection between Hibernate OGM and data store. Grid dialect abstract how data itself, including associations, are persisted. Think of them as a JDBC layer for our NoSQL stores. Other than this, all the create, read, update, delete CRUD operations are implemented by the Hibernate ORM engine, object hydration and dehydration, cascading, life cycle, etc. As of today, we have implemented following data store providers: a hashmap based data store provider for testing, and InfiniSpan embedded data store provider for persist your entities in an InfiniSpan instance running within the same JVM, and InfiniSpan remote data store provider to persist your entities in InfiniSpan over a remote hot rod client, and EHCache based data store provider to persist your entities in EHCache, a MongoDB based data store provider to persist data in a MongoDB database, a Neo4j based data store provider to persist data in a Neo4j graph database, a CouchDB based data store provider to persist data in a CouchDB document store experimental, a Cassandra based data store provider to persist data in Apache Cassandra experimental, a Redis based data store provider to persist data in the Redis key value store experimental, and Ignite based data store provider to persist data in the Apache Ignite experimental. To implement JPQL queries, Hibernate OGM passes the JPQL string and calls the appropriate translator functions to build a native query. Since not all NoSQL technologies support querying, when lacking, we can use Hibernate search as an external query engine. Hibernate OGM best works in a JTA environment. The easiest solution is to deploy it on a Java EE container. Alternatively, you can use the standalone JTA transaction manager. Here you can see object model is inside application. Application interacts with JPA or Hibernate native APIs. JPA or Hibernate native APIs, Hibernate OGM core, Hibernate ORM core, data store provider and grid dialect, and query engine are inside Hibernate OGM. JPA or Hibernate native API interact with Hibernate ORM core. Hibernate ORM core delegate persistence load queries to Hibernate OGM core. Hibernate OGM core delegates data store CRUD operations to data store provider and grid dialect. Data store provider and grid dialect interacts with data store. Here Hibernate OGM core delegates queries to JPQL parser. JPQL parser and data store query translator are inside query engine. JPQL parser delegates queries to data store query translator. Data store query translator execute native queries execute native queries, and data store query translator is connected to NoSQL data store via execute native queries. Now this is the end of my presentation. Thank you very much for watching it.